Okay, in example 32, we've got some data here. It says the mean lifetime of a certain tire is 30,000 miles and the standard deviation is 2,500 miles. So we know X bar, and we know standard deviation S. So we have part A and part B. In part A, we're going to assume, if we assume the mileages are normally distributed, approximately what percentage of all such tires will last between 22,500 and 37,500 miles? So what we need to do is get this, since we know they're normally distributed, or if we assume that they are, what should come to mind is the empirical rule, that we are going to somehow apply the empirical rule, and that is stated in terms of how many standard deviations away from the mean something is. So that's what we need to do, is we need to figure out how many standard deviations away from the mean each of these values is. Another way to say it is to find the z-score, right? So let's figure out how far away, let's find the z-scores for these values, how far away from the mean they are. So for an x value of 22,500, so if you calculate this out, you should find that this is minus 3. So the 22,500 miles is 3 standard deviations below the mean. And for the 37,500, you calculate this out, we should get, looks like positive 3. So that's 3 standard deviations above the mean. And so these two z-scores, minus 3 and plus 3, that means that if we want to know what percentage of all such tires will last between 22,500 and 37,500 miles, we don't know what percentage of all such tires will be within 3 standard deviations of the mean. Again, because we are assuming that these are normally distributed, that means that the empirical rule tells us that this will be 99.7%. Now, what if we change this question just slightly? What if we don't assume anything about the distribution? So we can't assume that they're normal. Approximately what percentage of all such tires will last between? These are the same 2 values. So again, within 3 standard deviations. So now we know that we can't assume that they're normal, so we can't apply the empirical rule, but we can still apply Chebychev's theorem. Remember, that applies regardless of the type of distribution we have. So we'll use Chebychev. We know that the percentage or proportion will be at least 1 minus 1 over k squared. Here k is 3. 1 minus 1/9 is 8/9, or about 89%. So at least 89% will last between 22,500 and 37,500 miles. If they happen to be normally distributed, that grows substantially to the 99.7% that we calculated in part A.